But what really is the smallest? That definition is also constantly changing. A little more than 100 years ago, the smallest particle was thought to be the atom. Its Greek meaning is indivisible, sort of like a small ball bearing. It wasn't long after that the indivisible was divided. It was discovered that the atom was composed of smaller objects. Originally, only the nucleus and its circling electrons were known. Soon after, it was found that the nucleus could be divided into protons and neutrons. More recently, protons and neutrons were found to be composed of even smaller particles called quarks. However, it's difficult to call quarks a particle, a fact that will become more evident as we progress. Someday, even electrons and quarks may be found to consist of smaller building blocks. Lastly, neutrinos were discovered, and it could be forcibly argued that they are the smallest. Look at your fingernails. Find one that's about 4/10 of an inch square. At our distance from the Sun, more than 65 billion neutrinos per second pass through that small area. But they are so small that they almost never collide with other particles. A neutrino can pass through 10 trillion kilometers of lead without ever hitting a single atom. How is that possible? Let's put things into perspective. If a neutrino were the size of a golf ball, about 43 millimeters, a single hydrogen atom, by comparison, would be about 36.8 billion kilometers in diameter. That sounds like an easy target to hit, but the target is almost entirely empty space. Additionally, neutrinos do not interact with other particles. But they are vitally important. Neutrinos can change flavors, something we'll look at later. This is one of the reasons they do not interact with other particles. This fact is responsible for the preponderance of matter in the universe as compared to antimatter. Without this behavior, matter would not exist at all, and the universe would consist only of photons.